Hello, my name is Brad Friedlander. I'm a principal consultant at Magenic, working out of our Boston regional office. I've been with Magenic for 11 years, and I'm going to talk to you today about DevOps. We're looking at the best practices that are based on industry best practices as well as Magenic's experience in making it work effectively. DevOps is a superset of application lifecycle management. It includes, in addition to the normal code that we consider as part of application lifecycle management, includes infrastructure and configuration as code, and we use that to support continuous improvement. DevOps is a continuous cycle. It begins with planning, goes through the normal steps of coding, building, testing, and goes all the way through to deployment into production, monitoring the use in production, and then using that as feedback for the next stage of planning. It's also important to note that it's not a one-way circle that goes all the way around and then starts again. As you go through, you may get to, for example, a place in tests where there's a recognition that there's things that need to be changed, at which point you might go back to a little bit of planning and then into code, build again, and back to test. So it needs to be looked at as a continuous cycle on the outer circle and possibly some inner circles that go with it. DevOps is not just something done by development. It's not something done by operations. It is a collaborative effort of the two to formulate both the processes that are going to be used and to execute it. We'll be talking later on about the roles and responsibilities of each in this. In this context, engineering are all those people that are involved in creating the application or the code that needs to be deployed to production, and operations is those responsible for keeping it up and running correctly. DevOps consists of three main sets of things: capabilities, processes, and tools. The goal of DevOps is sustained engineering. This means that we want to be able to deliver value to the business at the appropriate level of quality that the business needs, and do it at a consistent tempo and have this be repeatable over time. A successful DevOps implementation requires certain essential capabilities. The first set of these are source control, scalable branching, and test case management. Source control is extremely important. It is the foundation on which much of the rest is based. It needs to be a single source of truth for everything that exists in the environment. Another capability that's important is an automated build pipeline. This handles deployment and rollback is a critical part of the capabilities. It's not just deploy, but the ability to undo something if it's found that it's not working right and we need to go back to where we were. Automated build pipelining needs to include testing, and it needs to include an assessment of the code quality and safety. So this is security, quality of the code, other aspects that impact the business. DevOps also requires that we introduce monitoring and management. The key part of this is that we need to collect system metadata. And the system metadata is information about the DevOps processes. It gets linked to produce a meaningful picture of the DevOps cycle, what it takes to get things done, what our levels are of work, quality, velocity, and all those other attributes that we want to be concerned about, and does it through the entire life cycle of DevOps, not just for dev and not just for build or testing. It links together stories, requirements, issues, bugs, code changes, deployments, and any other thing that a business or organization feels is an important part of their DevOps implementation. DevOps needs to be supported by a number of processes, and they need to be consistent across all the engineering disciplines. So engineering disciplines might be, for example, those that are doing websites, and web services. Those that are designing and developing databases and stored procedures might be another group. Those doing reporting, such as using SSRS. Those that are doing integration work, maybe using SSIS or other things. Those are different disciplines, but they should all be using the same processes, and they need to be consistent. The processes need to mesh with the culture of an organization, so we can't go in and put in place processes that are in conflict with what a company's values are and how they do business as a general rule. Having said that, it's important to keep in mind that some cultural elements in a company will need to evolve so that they can actually begin to take advantage of the benefits that come from DevOps processes. An example of cultural elements that may need to evolve is manual steps that are done because people have silos of responsibility and they're measured based on what they're doing within their silo, and that culture needs to change to being one that's not a siloed set of relationships and responsibilities, but one that takes in the company as a whole. Processes definitely need to use automation, and we'll be talking about these again later, but there's continuous integration, so the process of as code is developed and checked in, it's merged in with all the other checked in code, and we don't have multiple sets of merging code, so it's one. Continuous deployment is the process of as code is checked in, we deploy it to environments, initially to dev for dev testing and then to others as appropriate. And the third type of processing is continuous testing, again based normally on check-ins or promotions from one state level environment to another. We'll kick off the testing and have that be an automated part of the DevOps workflow. All the processes that are part of DevOps need to produce metrics. The metrics are what we end up measuring by to understand if we're being effective, if we're improving, and to identify areas for improvement. The process flows and gates need to be consistent across all the engineering disciplines. So continuous integration typically controls the development of test environments as being a gate. When you check in, it kicks off things in those particular environments. For environments such as user acceptance testing, staging, and especially going to production, QA tests, as well as potentially things like release management, need to be the gates for those environments. DevOps, because we're trying to automate things, is highly dependent on tools, and these tools need to support the processes and provide the capabilities that we've discussed on the last two slides. The tools need to provide a unified view of the system metadata for the critical tool functions. So the unified view means that we need to be able to pull together, if we have multiple tools, which many organizations do, we need to be able to pull those together in a way that we can see the entire cycle of what's going on and not just a piece of it, which would give us potentially a warped perspective of what's actually going on in the DevOps processes. The critical tool functions include a lot of different things. It's source control, it's automated build, automated packaging. We talked about the deployment and rollback. That needs to be automated. Testing, unit and integration testing need to be automated. There's some types that are testing that are more difficult to automate, and those may require manual steps, and then automated configuration for each environment. The real benefit for the business of these essential capabilities, processes, and tools that we've discussed is that it improves the ability of the engineering and IT organizations to develop solutions faster, to deploy solutions faster, to reduce the errors in the development and deployment process, to reduce the vulnerabilities and problems that occur in production. In other words, to make things better for the business and to increase the velocity of being able to address the needs of the business as they change. As we mentioned before, DevOps is the responsibility of multiple parts of the organization, both the engineering organization and the operations organization. DevOps must encompass operability and operations. Operability is the responsibility of the engineering team, and the engineering team includes business analysts, configuration, development, testing, and other things. The architects would be in there, other people that are part of putting together both the concepts, the designs, and the actual code that needs to be done. The operations or system operation is the responsibility of the IT team. And this typically in an organization will be those people responsible for operations, for security, for managing the infrastructure, for doing release management, and it could also include DBAs as part of that. There's each organization that we deal with has a different structure, but all of those people are part of the system operation, and DevOps needs to encompass what they need and what's important for them. As we said, operability is the responsibility of the engineering team. So what does operability actually constitute, or what constitutes operability? The first is deployability. This means that we have documented the means for the operations to correctly deploy. This documentation may actually be a fully automated deployment or maybe partially automated, but the important thing is that whatever manual steps are involved, even if it's only to one command to click things off, needs to be documented so that it's clearly understood and is repeatable by anybody, including those who have never seen the solution before. There typically need to be control points, particularly when you're talking about deploying beyond the dev environment, and those control points or the gates are gated by continuous testing results, as well as QA testing and business decisions by groups such as release management. And the last thing that's very important in deployability is that there must be a DVT, a deployment validation test, and it is used to validate that all the settings are correct, so that making sure that what you think you deployed is what you actually deployed. The second responsibility of the engineering team is in configurability. And this means that we specify the right settings for the right environment. We know that server names will change from dev to test to production. Many other settings, even accounts, user accounts, system accounts will change. And those need to be part of the configurability. So you have security, you have connections, and any other name value pairs that will vary from one environment to another. What this means as part of DevOps is looking across all the environments, identifying what is different in the configuration in each environment, pulling that out so it becomes parameterized and can be part of the coded configuration for deployment. The last thing that comes under operability is operational visibility. Again, the engineering team is responsible to make sure that health and behavior information is available for operations to see. And this means typically working with operations to understand what kind of information they need to do their job well. And it also means to some extent working with the business to understand what they need to understand what's going on. It consists of logs and diagnostic streams, real-time health checks. There are other things that be added in there as it meets the business requirements. As we said before, the system operation is the responsibility of the IT team. The question is, what does system operation include that comes under the rubric of DevOps? The first thing that we look at is business continuation. This means that they need to be able to monitor and manage the solution. They need to be looking at how to scale it, when it needs to scale, and how to scale it. They need to be able to address durability, which is the issue of addressing problems that occur, repairing problems on the fly, restarting, whatever other mechanisms are needed so that the solution is kept alive and running and serving the business. And the third thing that business continuation is viability, and this is the ability to adapt to changes over time within plan parameters. And this may be as simple as scaling to handle a normal workload that represents, let's say, 1x, and peak workloads that range from 3 to 5x. If the design parameters from the business were to go to 1 to 5x, and all of a sudden you have 10x, that doesn't come under viability. That has to be handled separately because it wasn't a planned set of parameters. Operations also needs to be working on operational excellence. So they need to be able to produce actionable metrics. Engineering help create the metrics that the operations can look at. Operations needs to pull those out, put them together in such a way that either IT/development can take action on them to make changes or to do something, or they can be provided to the business to give them things to use for planning to improve in the future. Operational excellence also includes business continuation and disaster recovery, and making that transparent to the business as to what's going on. There's a lot of work that needs to go in there in terms of the planning that engineering is going to have to do to help support both the business continuation and disaster recovery. The last thing is proactive planning with the business, and this is operations working with the business to give them advance notice of things that are happening or going to happen or changes that are going to occur. Do work together with the business to do scalability planning. Again, it's a cooperative venture. They have to provide it because they need to sometimes provision additional resources in order to support the kind of scalability that's desired, and sometimes engineering is going to have to come back in and make changes to support that scalability. And the IT team together with business have a joint ownership of the risks and vulnerabilities for DevOps. I wanted to make one important point about business continuation. The real ultimate goal of business continuation is to not lose customers. Customers may be external to an organization, or they may be internal customers, those that are using systems such as in corporate headquarters. Not losing customers means some very important things. One is not losing the data, the information. Second is not losing availability. It needs to be there when it's needed. And third is not losing trust. So not giving information away, having security violations or leaks that endanger the business, the organization, or the customer. During the last few minutes, we have been covering DevOps best practices. Again, these are the combination of industry best practices and combined with the experience that we in Magenic have had as we've helped our clients implement DevOps in their organizations. I'm Brad Friedlander. I hope you've gotten something of value out of this session today, and I look forward to discussing with you in the future.